So we have kind of a review day. All right, we're going to do some problems randomly. The first one is prove f of x equals 3x cubed minus 7x is odd. First of all, it's a polynomial. Domain is all reals. You should recognize it since it's x cubed that the range is all reals. But I didn't ask for that. I asked you to prove it's odd. Whoops, I guess I grouped it. And I said, reminder, if you're going to recall, if you're going to prove odd, you have to remember that f of negative x equals negative f of x. What that means on a graph, guys, real fast. Bless you.
Thank you.
All right, good job, Derek. That'll be locked in YouTube forever. All right, now, is if you plug in a value of negative x here, you're going to get a point here. Well, on the opposite side, it's going to be mirrored down here. That's what this means. That's what odd is, okay? That said, I have to prove it. So if I'm going to prove it, I'm going to put negative x in the function. And that's going to be 3 times negative x cubed minus 7 times negative x, which becomes negative 3x cubed, because it's an odd. Negative is a positive. Well, if I want to show this, I have to show this negative original function. So I will factor out the negative. And looky, what did I just do? I come down here and I write this. I can rewrite this as that. And I don't need the parentheses, actually, so let's get rid of the parentheses. And think, I know odd functions are this. What did I just end up writing? That. Whoop. All right.
So, like, I was looking at it, and I put, like, the negative out, and then I, like, multiplied it, and it, like, matched.
That would be the same. I'd give you
Okay.
credit for that. On the long term, you want to try to do it in function notation the way it's shown on the board. All right, so number 2, which says draw a sketch. So I'm going to go with the sketch. I don't want to make a good function. A function where it has 2 limits, a positive limit from the right-hand side of 3, a negative, the left-hand limit at 2 of negative 1, and the value of the function is 1. Everybody should see this as a jump. You should see this as a jump. So all you got to do is make me the jump. Remember, label the axes. I take points off for it. At 2, boom. It's 3 from the right-hand side. So there's 3 from the right-hand side. It is negative 1 from the left-hand side. The world's most unscaled drawing. Boom. And at f of 2, it's 1.
So do you put arrow?
Sure. That means the function goes forever. Fine.
You always leave it open.
You have to be open because otherwise that's not a function. Listen, if you guys accidentally did this, that is no longer a function. I want functions, right? And when they're not functions, it's a different set of rules. We will not deal with that immediately, okay? Everybody remember, if I do this, I box this in. This one is coming down the tracks this way from the right-hand side. That's a right-hand limit, right? To the right side, come in. Now, some students get confused because they say, Mr. Anderson, a right-hand limit comes towards the left. Yes, go to the right-hand side and see what happens when you go towards the point. That's the way to think about this. The left-hand side goes this way. Guys, they just approach the values. And what confuses students, let's be clear, the limit and the value of the function don't have to be the same. All right? Pretty easy. The truth is, we're going to start making these very complicated. I'm going to give you like 8 conditions like this, not just 3, and you will make me a whole function. Okay? Because I can give you infinite limits. We got to start doing those things. But this is review so far. This one, number 1 rule, expand it out. It's expanded out. Does everybody agree? Number 2 rule, factor. Let's factor. This jumps out and says, factor me, factor me. I am the difference of 2 squares. Don't work hard, work smart. Don't make algebra 1 mistakes. You make enough algebra 1 mistakes, I put a freshman with you. All right? You just sit there and check all your math. All right? Cancel these out. How about 3 plus 3 is 6. Everybody, first step you should have done is plug it here and say 3 minus 3 is 0. Can't do it, right? That is your first step. But often, we don't do limits in uninteresting places. All right, so there are some examples. I'm going to pause the video and we'll put up some more problems. All right, for the next problem, I have a math teacher shot vertically at 40 meters per second, probably from a cannon. What is his average velocity at? Time equals 1 lasting 1 second. Time equals 1 lasting a half second. Time equals A lasting h seconds. My big recommendation is you do little Roman numeral 3 first. Alright, because if you do Roman numeral 3 first, we can put in for A and H using the 2 before it. This is, again, a very typical calculus test problem by professors where the third part is much easier to do first. I'll give you the function. The position of the math teacher is h of t equals 40t minus 5t squared. Guys, this is absolutely a secant, and then we're going to add another section of this where I ask you for the tangent. We're going to do average, and then we'll do instantaneous. So we got this function, and the first thing I hope you recognize is that it's a parabola opening down. And one thing we could say, I don't care about the graph that much, but we should see, by factoring out the t, that t equals 0 and t equals 8 are the x-intercepts. So I shoot a math teacher up at time 0, I'm at the tip of the cannon. 8 seconds later, I'm at the tip of the cannon again, fired straight up. This is not a path of, this is not my path of travel. This is how high in the air I am, where this is in meters. I should have put the units on this, and the bottom units are in seconds. Now, you could do 1 and 2 first. I don't want you to. We should do number 3 first, and then use the equation from Roman numeral 3 to do 1 and 2. So I'm going to draw on the graph, and I'll do it at 1. T equals A. Boom. Well, Christmas. Okay. So, 1. And to exaggerate, I'm going to put H all the way across so we can really see a secant line. I'm going to put the other point, A plus H, way over here. I'm going to call this point P and point Q. And this is a secant line, 2 points. That is the average velocity between A lasting h seconds. Well, A plus H is A plus H. The resulting y value at P is f of A. And the resulting value at Q is f of A plus H. Or I suppose this time it's not f, is it? I suppose this time I should be using the function name h. So I'll make that small change. Alright? And if I do that, it's just h of A and h of A plus h. Again, the average velocity is the slope of the secant line. Look at the units. Meters divided by seconds, right? The slope, meters per second. Average velocity. Distance per time. Alright, so, didn't need this. Helped me make a really pretty graph. Alright, I know 80 because a parabola, once you find that, has an axis symmetry in the center. Midpoint of 0 and 8 was 4. I put 4 in. Point is, the graph's not needed. What's needed now is this. I want h of A plus H minus h of A all over h, realizing that this is a function h and this is the lasting time of h, not the same h, right? Different h's. All right, let's grind it out. Now it's just some function notation stuff. So I plug in A plus H into the function. Right there, right? 40t minus 5t squared. So when it's A plus H, it's 40a plus H minus 5a plus H squared. All right? Minus the quantity, 40a minus 5a squared. Have you guys noticed that every time I do this, I always put this in parentheses? I never miss a sign here because I do that. Whatever system it takes for you not to screw up. All over H. Here's where you need your freshmen. This is where 90% of our problems come. You have to recognize this as a trinomial. So maybe just to help everybody out today, I'll even write it out. I never not put over H. I never just write the numerator. That's a bad idea. It takes 1 second to put the line in the H. Now I'll do the last distributing. And if it is a function, let me say this clearly. If what you're doing, the equation you're working with is a function, every time you get to this step, everything that does not have an H has to cancel. If it doesn't cancel, one of two things is happening. You either don't have a function, All right, and that's a whole different set of rules, all right? Which is not the case for us for a long time. The case for us is you have screwed up, and you have made a sign mistake or a multiplication mistake or a binomial expansion mistake, and you must go back up into this area and find your error. Everything without an H will always cancel, and then because you have an H in everything, you can factor H out and write. And I'm just going to write the answer now, taking out one H out of each term. This. And that is the answer for Roman numeral 3. All right. Once you get 3, you can do this 20,000 times. I'm going to group, oops, no, I don't want to erase it. I'm going to group all this because I will tell you on my tests, I will give you a problem like this, all right, where the last one's this, just like every calculus teacher ever does at college, okay? I do what they do. I am simply your servant to prepare you guys for college. All right? I am a customer service guy. All right? That said, once I have this, on the test, I might give you 15 conditions up here. It won't be Roman numeral 1 to 3. It'll be Roman numeral 1 to Roman numeral 15, and the first 14 are just conditions. And it's really easy as long as you have the equation. What does that do? It's called a time sucker on a calculus test. If you are actually plugging in on Roman numeral 1 and doing this, and this works, but I don't want you doing it, you can say, oh yeah, I know I can go h of 2 minus h of 1 over 2 minus 1. Right? That is the average. That works. But if you do that 14 times, you'll have no time left for any part of the test. Calculus teachers love doing this at college. You must understand the variable. I don't want you doing it this way. It works. I guarantee you'll get the same answer. What we're going to do is say, oh, now that we've generated the equation, all right, I'm going to do Roman numeral about 1 saying, hey, I know that started at time equals 1, A. It's lasting 1 second, which puts me at 2, but I don't care about the 2. I just need to know the H. 40 minus 10 minus 5. How about 25 meters per second for Roman numeral 1? Roman numeral 2. A equals 1, H equals 0.5. 40 minus 10 minus 2.5. How about 27.5 meters per second? All right. Now, the last thing these problems always ask for in the textbook, always ask for on tests, all right, is there's always going to be a part B, or Roman numeral 4. And that's going to be a situation of now we've generated this awesome equation, all right, 40 minus 10a minus 5h. And I don't have to do it at 1. Let's do it at a different time. Let's find my instantaneous velocity at 3 times. How fast am I going now? We'll do it at 1 just because it's fun. So what is my instantaneous velocity at time equals 1, time equals 4, and time equals 6? All right. This is really easy. All right. You should be able to look at the board right now and determine, you should be able to plug these in and determine these immediately. Because instantaneous velocity means that the h is going to 0. Guys, for the equation for instantaneous velocity, we're going to take the limit as h goes to 0 of our answer here. So guess what happens to the 5h? It goes away. And all I have to do now is go for time 1, plug in 10, 40 minus 10. I think the first answer is 30 meters per second. That's my instantaneous velocity. I like 4 seconds because that's the peak of that's as high as I was, right, on our graph. And look what happens. I get 40 minus 40. There's an instant when you get thrown in the air at super high speeds where you feel like, oh, things are going to be okay. Then you start going back down like Bugs Bunny. And lastly, then you realize going back down, oh no, Batman, I am in deep trouble. Why is it negative? Because you're going down. We call it up positive. If I would have said, if I could have changed everything and just changed signs up here, and then all the signs would change all the way down, but we're not going to do that. Again, we made up positive. Often we can do what we want. Everybody, this is a classic problem. This is what we will do in Chapter 3, but there are shortcuts, all right? Because I can tell you immediately the instantaneous velocity without all this work. I can look at this function right here, the h of t, right at the bottom where it's splashing. And I can tell you these answers we just did. Not that hard. But we will let you grind through the proof side for a whole chapter before I show you. All right? All right, I think that's enough for today. Albany, this is for you. Merry Christmas.